Hi everyone, so this is another topic from the electric field in lines, electric dipole. A pair of equal and opposite charges separated by a small distance is defined as electric dipole. The dipole moment is used to measure the strength of electric dipole. Suppose two equal point charges which are oppositely charged, minus q and plus q, which are separated by 2a distance. Here the a distance is the distance between the center of both of the separation of the charges to either of the charges. So a is the distance between the center and either of the charges. So to calculate the dipole moment, we multiply the value of either of the charge into the distance of separation between them. Here we can see that the charge is q. We have to take the magnitude, so we are taking the q charge, and the separation of distance between them is 2a. So dipole is denoted by this symbol, which is equals to q into the separation between them, which is equals to the 2a coulomb meter. So by this equation you can calculate the dipole of any of the electric dipole by multiplying the charge into the separation between both of the equal and opposite charges. Some of the example of electric dipole are H2O, HCl, C2H5OH, which have dipole moment. So now we will derive an expression for the electric field at an actual point of an electric dipole. Suppose 2 point charges minus q and plus q, which are separated from each other by a distance of 2a. Suppose a p point, and we have to find the electric field due to minus q and plus q charge on the p. The p point is separated from the center of both of the charges by r distance. So we know that the electric field lines for the positive charges is always away from the charges, from the given charge, and the electric field for the negative charge body is always towards the charge. So we can see that the electric field due to plus charge is away from the q charge, and electric field due to minus q charge is towards the minus q charge. So the p will experience two kind of electric field. So we can say that electric field due to minus q charge is equals to q upon 4 pi epsilon naught into r plus a square. R plus a is the distance of separation from center to the p is separation of minus q and p charge. So we are using p cap for the vector form. This is the electric field due to plus q charge, which is equals to q upon 4 pi epsilon naught r minus a square, which and p cap for the vector form. R minus a square is taken because the distance between plus q charge and the p point is r minus separation between the center and the q charge, which is a. So now we will calculate the total E net, or the total or resultant electric field experienced by the p point, which is equals to E plus q minus E minus q. Both the electric field are opposite in direction, so we will find the net field experienced by the p charge. So here p minus charge is taken. So now E net is equals to q upon 4 pi epsilon naught r minus a whole square minus q upon 4 pi epsilon naught into r plus a square. We have just written the values of E plus q and E minus q. So now the electric field is equals to, by taking q and 4 pi epsilon naught common, we are left with 1 by r minus a whole square minus 1 by r plus a whole square into p cap. So now electric E net equals to q upon 4 pi epsilon naught. We have taken the LCM and multiplied the denominators with each other. So now we have got r square plus a square plus 2ar minus r square minus a square plus 2ar upon r square minus a square ka whole square. So now by solving this equation, we get q into 4ar upon 4 pi epsilon naught into r square minus a square whole square into p cap. Now we have got that the electric field is equals to q into 4ar upon 4 pi epsilon naught into r square minus a square whole square by p cap. We know that the 2a into q was equals to the dipole moment, so by putting the value here you can see that 2 is getting multiplied by q and a. We can write 2 into dipole moment into r, which is separation upon 4 pi epsilon naught into r to the power 4. As if we are taking here a at as a very small value, so we can say that the square of a very small value is negligible. So by neglecting a here, we get r square upon square, which is equals to r to the power 4. So now we can write that the total E at axial is equals to 2 dipole moment. Sorry, I have written it 2 times. Sorry, let me correct it. This is 1 upon 4 pi epsilon naught into 2p upon r square p cap. Here p is a dipole moment and this p is the showing the direction. We can now see that the E axial is positive, so this shows that the electric field is from negative to positive. So we can say that the electric field is working towards from left to right direction. So thank you.